Hey everyone, today we're starting our new unit which is on electricity. We're going to spend a while on this, so make sure you save this note packet document somewhere, you'll be able to find it easily. So let's go. Today we're just going to talk about charge, like electrical charge, like what is electricity, where does it come from, why is it there, and that'll be it. So nice and quick today. And a lot of this should be a review from your chemistry class, so let's see how this goes. Let's start with this. Electrical charge, like what is it, like where does it come from? Well, all objects are made. I wrote in like half the notes this time. All objects are made of atoms. Something you should have learned before in your science class. So atoms are like are really, really, really small units of matter. It can be sort of all different elements. All objects are made out of these atoms. But what are atoms themselves made out of? Well, they've got smaller particles within them that we'll look at in a second. But some of those particles are charged. So atoms contain charged particles. So atoms contain these charged particles. And all electrical charge is really just the result of these charges existing in certain or different amounts. So all of this electrical charge that you could feel, like a static shock or moving electricity, is these tiny, tiny, tiny subatomic particles moving around and sort of interacting with the area around them. So let's look at what's in an atom. Again, hopefully a lot of this is review for you. The atom consists of three different particles. They are the protons, the neutrons, and the electrons. So these three different things combine in a certain structure to create your atom. Protons. Protons are positively charged. Positively charged. So, and they are located inside of the nucleus. So, like here, let's label all these. Let's say the red ones are protons. You really can't tell which is which, but so let's make that. Let's give that a P. So protons located inside of an atom's nucleus, and they are positively charged. Neutrons, kind of like the word sounds, are neutral. And what that means is that they have zero charge. They have no sort of electrical anything. So when we talk about an object having a certain amount of electrical charge, these neutrons really don't contribute a lot. So they are in an atom, but for our purposes, for this topic, they're not super interesting because, again, they don't have really any electrical properties. They are also inside the atom. So let's make the white ones here. So the neutrons are also inside of the atom. So an atom consists of a couple of protons and a couple of neutrons that are bound together. Electrons are our negative particles, so they exist inside of an atom as well. Now, electrons are located on the outside of the nucleus. They orbit the nucleus. So kind of like this. This is kind of like a simple picture of an atom. We have our protons and neutrons inside of it, and then the electrons on the outside. And again, these protons are positive, the electrons are negative, and the neutral objects have no charge at all. So that's an atom. A lot of atoms are electrically neutral. When an object is neutral, it has a balance of protons and electrons. Like it's got like 4 protons, 4 electrons. They kind of cancel out. Like plus 4 minus 4 gives you a total charge of 0. Now, when an object becomes charged, it occurs because of an imbalance of protons and electrons. So if these two types of particles are balanced, the object is neutral because they sort of cancel each other out, the positive and the negative. But if there's an imbalance of these, then it becomes charged. If it has more protons, the object will be positive. If an object has more electrons, the object will be negative. So that's how you can tell if an object is positive or negative. But when charge moves, so basically you can think of like this atom, right? This atom, the way I'm looking at it, is neutral. And the reason I'm saying that is I think we've got like 1, 2, 3 electrons, and 1, 2, 3 protons, Plus 3 minus 3 gives you a total neutral charge. But let's say we wanted to charge it, like give it a certain charge. Well, the only way we can do that is by moving electrons. So only electrons. Only electrons move when charge is moved. So, if I wanted to give this object some electrical charge, I could remove an electron, which would make it positive. Or I could add an electron, which would make it negative. Protons cannot move. They have no ability to do this. They're inside of this nucleus and they're sort of very much stuck there. So protons won't leave the nucleus or jump back in, but electrons, which are way on the outside, so it's kind of easy to remove them or add them, electrons can be added or removed. So only electrons move. So all charge exists because of this movement of electrons to create a balance or an imbalance. Okay, let's do some work with this. We'll do numbers, we'll do like 1 through 6 together. I'll have you try the rest on your own, and we'll be good. So number 1, lithium ion. So I'm going to throw like a lot of like sort of elements and sort of the scientific jargon at you, but we don't necessarily need to know all of it. A lithium ion has 3 protons, 2 neutrons, 2 electrons. Is the lithium ion positive, negative, or neutral? So, to do that, let's think about all these individual particles. 3 protons. What's the charge of 3 protons? Well, I think it's plus 3. 3 because there's 3 of them, and positive because, like I said up here, protons are positive. So that's a fact that you need to remember. 2 neutrons, well, how much charge do those contribute? 0. Neutrons are neutral. They have no electrical charge. So for what we're doing, we can kind of ignore them. Again, they do exist, but electrically they're just not super interesting. And 2 electrons. Well, electrons are negative, just like I said up here, and again, you have to remember that. I'm going to say negative. They contribute negative 2, because again, there's 2 of them. Plus 3 minus 2, I think, gives you a total charge of plus 1, which is positive. Now, you could have answered this question without really doing the math. Like I said here, charge occurs because of an imbalance of protons and electrons. We have more protons than electrons, so it's positive. And so we could kind of answer it without tallying them all up individually, but it's good to look at. Number 2. An oxygen molecule, O2, has a total of 16 protons, 16 neutrons, 16 electrons. Is it positive, negative, or neutral? So remember, we're looking at a balance or an imbalance of protons and electrons. We've got 16 protons, 16 electrons. I think that's a perfect balance. We got plus 16, minus 16. This object is neutral. It is not positive or negative. It has a total charge of 0. 3. A typically neutral object becomes negative. Why did it become negative? What happened in the object that caused it? So this is kind of a tricky question here. I'll explain what I mean. So objects become negative because these charged particles move around. The charged particle that moves is always electron. So it's always the movement of electrons. Now this object became negative. So we got to think, did it gain electrons or lose electrons? Well, electrons are negative. So I would say that what happened is it gained electrons. Think of it like this. We've got this object. It's I don't know, it's just some circular whatever. And I want to make it negative. Well, I can do that by taking electrons and adding them to the object so that now it becomes negative. And that's how we would do that. So it gains electrons, it becomes negative. What is the charge of a neutron? Well, we said they're neutral. So I would accept 2 different things. I would accept the word neutral, or I would accept 0. Both perfectly fine. What's the charge of 100 neutrons? Well, if one of them is 0, then 100 of them, 100 times 0 is still 0 or still neutral. So I'm trying to bring up this idea that electrons, not super interesting in the electrical department. 6. Is it true that a neutral object has no negative charges in it? Explain your answer. So, what I mean by that is, if an object is neutral, is it true that there are no negative things inside? The answer to this is false. That is not a true statement. A nice example of it is up here, number 2. See how this one we had 16 protons, which is plus 16, and we had 16 electrons, minus 16. They canceled out to make a neutral object. But it did have negative things in it, right? It had these 16 electrons. So I would say that the best way to say this is false. I would say it has like what's the simplest way to say this? Like an equal number of protons and electrons. It's very sloppy. It says electrons. I think my computer's getting worse by the day here. So it has an equal number of protons and electrons. Okay, so that was good to do together. I'd like you to try questions 7 through 12 to sort of wrap this up. A lot of just dealing with this idea of how can you tell if an object is positive or negative and what happens to do that. So pause the video here and try the rest. I'll just give you a second to pause it. That's the worst coffee I've ever had. Ugh. Okay. So, let's go. Number 7. An object becomes positively charged because it blanks. Alright, if an object is positively charged, I want to start with this. Only electrons move when charge is moved. If there's like one thing I really want you to remember today, it would be that one. Okay, so does it gain protons? No. Does it lose protons? No. Protons do not move. So to become positively charged, again, it has to be the motion of electrons. It has to be. That's just how the world, the universe is designed. Does it gain electrons or lose? I would say it loses electrons. Here's a nice way to think of it. Let's make a neutral object. 2 positive, 2 negative. Everything's nice and balanced. So I want to make this positive. But again, I can't move these positive protons. I cannot do it. That just does not happen. Well, I can't add positives to it, so what if I took away a negative? Because again, electrons can move. This is like an allowable thing. Okay, well, this is positive now, right? Because you see how it has more positives than negatives? So that's why it makes sense that it loses these electrons. But again, these protons, they never move. 8. An atom has 50 protons, 51 neutrons, 51 electrons, positive or negative. Again, we're comparing protons to electrons. So I would say it's negative. It has more electrons than protons. When a balloon is rubbed against fur, this sounds random, but we would have done a lab involving this in class if we were in class. The balloon takes electrons away from the fur, so the balloon takes the electrons away from the fur. Is the charge on the balloon positive or negative? Well, it sounds like the balloon took the electrons, and if you gain electrons, you gain negative things, and you become negative. Now the fur lost electrons, it lost negative, and if you lose negative, you become positive. When an object gains electrons, does it become positive or negative? Well, electrons are negative. So if you gain these negative things, you become negative. A charged rod has 1.5 million protons and 1.2 million electrons. Positive or negative? Well, 1.5 million to 1.2 million. I think we have more protons, and so this will be positive. And lastly, 12. I didn't really go over this. Why do electrons move instead of protons? I kind of mentioned it. But the reason for this is they are outside the nucleus, which means that they are free to sort of move around, rather than the protons, which are stuck inside of the nucleus and unable to move around. Alright, that's it. So as long as you can as long as what I'm looking for you to know here is that a charge is the result of these protons, neutrons, and electrons, and that we can charge objects positive or negatively by moving electrons. If an object has more protons than electrons, it's positive. If it has more electrons than protons, it is negative.